Welcome to a cleared wetland. Today we're going to talk about Toisnot Series. This is one of the few series in North Carolina on the coastal plain that has a mapped fragipan or fragic soil properties. And as you can hear, it's pretty dense. So we're on top of that fragic layer and we cannot really get any traction, just a little bit. So stay tuned. We'll look at the soil. So believe it or not, here in the coastal plain of North Carolina, we have mapped series that are fragic or fragic soil properties. This is one of them. We're on the upper coastal plain right now near Clinton, North Carolina, and this was forested wetland until not too long ago. And as you can see, the trees have been taken down and this site's being prepped for row cropping next year. And obviously this is not prime farmland, so on this part of North Carolina you'd want something like a Norfolk series, a Goldsboro series, a Lynchburg series, or even a Rains series. Rains is a highly productive altisol that's wet. It's a poorly drained soil. This as well as a poorly drained soil, but there's additional issues for growing plants. And the major issue is the fact that you have these fragic soil properties or really dense materials at depth. It doesn't allow for root penetration, but it also holds water up at the surface. So this is what we call episaturation. So this site will be extremely wet come springtime when we have a lot of infiltration of rainfall and not any evapotranspiration occurring because the plants have been cleared. I would bet money that this site is going to have surface water all through it in the spring this year. So here in a minute we'll look at the soil morphology of Toisnot series and what makes it different than something like a normal poorly drained altisol that's workable for agriculture here on the coastal plain. So what we have here is a nice example of an auger boring. So we took the hand auger, we crank it down 15 centimeters at a time, and we lay out the horizons in a nice tray like this. And we'll show you at the end why we put it in a tray, but you can basically tip this up and put the soil back the way it came out. So augers are very important for very quickly assessing soil morphology and the depth to different features and in any sort of land use capacity, but you're only getting a very small picture, maybe 3 to 6 inches across. So soil pits where we have nice holes in the ground are preferred because you can see in 3 dimensions how the horizons are changing in 3-dimensional space. But here this gives us a good idea in 2 dimensions, and especially at depth, what's going on under our feet. And so what we can see here going on underneath our feet here on this particular site is we have a really dark colored A horizon here. So the land use history of this site is it was used for past agriculture, and then it was taken out of agriculture because of low yields, and now it's been cleared again to go back into agriculture. And so for about 60 years or 50 or 60 years we've had predominantly trees on this site. And so because it's wet and you have a lot of biomass being produced by the mature trees that were here, we've built up a really dark colored A horizon here. We have really nice structure, really nice subangular blocky structure here. I would say this is moderate grade, so moderate subangular blocky structure, very dark color, a lot of humus, very indicative that this is a wet site. You know, obviously our really dark colors are related to lack of oxygen and lack of production of CO2. Below here we have sort of this interesting, almost like transitional horizon or combination horizon. And what you can see is sort of there's mixing. It's not as dark as above, but there's humus in here. And you got components of what's below being brought up into the material above. And this is very indicative in situations like this of probably past plowing. So this is likely like an AP, or you could call it a combination horizon, an AP slash whatever this material below here is. And the material below here is increasing in clay. We do have some pretty good structure We have subangular blocky structure again. So if you were to call this some type of combination, it would be an AP/BTG. So we have an uptick of clay below, and it's gray because of wetness. So as we move down, now we're down to about 39 to 54 centimeters in here. We have an uptick in clay, faint clay films. So we have the process of lessivage occurring. This would be our zone of eluviation of clay. And then the characteristics change again, pretty dramatically. Notice the structure has gone from pretty moderate to weak. Here's a good example. We're starting to get plates. So plates are elongated horizontally relative to vertically. And this is problematic for water flow because the water will come down and hit this and have to sort of migrate along the plates and then down. And so platey structure tends to impact water movement. Below this is the Fragic Zone here. This is typically mapped, when they map this as an EX or an EXG, because of our gray color here, we're going to call this an EXG. The X standing for fragic properties or fragipan. And this is a really neat section of the soil, so we're trying to get through it with the auger, and it's very difficult. And what we're doing is basically pulverizing this really brittle material. But every once in a while, we'll pull out the intact, looks like caps. So this would be the upper part, and water would come down and shed off of this and down through the soil. This is actually, if you're looking down, this is what you'd see. These are the outlines of large prismatic structure, or columns of prisms. So this is very interesting morphology. So what you're seeing here is the caps of the prisms, and then everything else here has been kind of chewed up by the auger. And just to show you how firm and how brittle this material is, just with my thumb and forefinger, I exert extreme pressure and that's not breaking. This is like very firm or even beyond. And when I start to break it, some of these will pop, which is indicating brittleness. There you go. There's a nice one. So when you really pressure on these, you'll see that the manner of failure is it basically explodes in your hand. And that is a sign of brittleness. And these are two of the characteristics of fragic soil properties or fragipans. If we were to drop this in water, it should slake. So what that's telling us is that it's not cemented. And what slaking means is it'll just fall apart. The aggregate will fall apart in water. This is a really unique soil type in the coastal plain. There's been many arguments over the years. Is this geogenic, which would make it like a dense horizon, or is it pedogenic, which would make it a fragipan? It's a very interesting soil, but this layer here is impermeable to roots and it's pretty impermeable to water. And so the water from the surface, when it rains, will come down and hit the top of these prisms, and the only place it can get infiltrate in this dense material is in between the prisms. So the prisms are lining up next to each other and we call interped pores, so the water can only move in between. And that zone is very minimal for water movement. And so because of that, you get a perched water table we call episaturation. And this is an episaturated, poorly drained soil, so the water comes down, hits here, backs back up to the surface. Periodically you'll get surface water in a place like this. So not only do you have wetness, you also have a root limiting layer here, very problematic for a lot of interpretations. So these sites are typically not prime farmland and they're not ideal to build on because of these issues. But this is a really interesting soil. I think it would be better to look at the morphology on something like this from a pit, so you could actually see the prisms and you could see the morphology, but we have an auger, and so this is the best we can do for today. All right, so once we're done augering, we have a hole here that's 3-4 feet deep, just a cylinder. And the reason we use the tray is ease of putting back the sample once we're done. So we just pick it up. Obviously the A here is at the top and the EXG is at the bottom. I'll just pick it up, align it with the hole, and each horizon is slid back into place in the exact same order it came out. And there you go, minimal disturbance. That's why we use the trays when making descriptions. All right, you want me to just pop up? Be like, hi, this is Matt Rick.
It's pretty funny.
Okay.